Our speaker this evening has worked on data warehousing integration tools at Oracle and is currently the VP of Engineering for MariaDB. Please welcome David Thompson.
Thank you. All right, so thank you all for coming tonight. I'm David Thompson. I'm one of the VPs of Engineering at MariaDB. I'm here with my colleague Bob Hesser tonight. He represents our sales organization for the New York area. So you'll see him if this piques your interest. All right, so tonight I'm going to talk about MariaDB ColumnStore. So this is a product that we launched last December, and it's very exciting. Because basically what it does is it kind of brings the ability for you to support both OLTP through MariaDB on MariaDB, as well as analytics with ColumnStore. So why did we create ColumnStore? So these are kind of the three sort of pillars we tend to emphasize. So better price performance. So compared to some of the legacy solutions from companies that I might have worked with in the past, this is an open source product that comes at a cheaper price point, so that's attractive to a lot of people. It's easier to consume. One of the things that we see a lot with customers is that if they're already a MySQL or MariaDB shop, it's very easy for them to adapt to ColumnStore because same SQL syntax, same connectors, etc. It's also easy to manage and scale. So you can kind of start small and scale out, and it's very light in terms of operations. And then finally, one of the things it offers is, what everyone ultimately cares about is speed, right? So ColumnStore, especially compared to, say, MariaDB, ColumnStore applies parallel query techniques. So both within a single server and across server, we can kind of distribute and scale our query execution. So ColumnStore, we don't really care where you run it. If you're on-premise or in the cloud, we're not going to dictate that you only run this in AWS or only run this on our hardware. You can use commodity Supermicro type hardware. It's an open source product, but we offer subscription-based packaging where you get value-added tools and support. Talked about this earlier, but a very attractive piece is that you're not really needing to maintain a third platform, tools, or training if you're already familiar with MariaDB. And then we try to be efficient with how we store data. So by default, we use compression. And so that allows you to store more data with less disk. Okay. Under our Easier Enterprise Analytics bucket, our single SQL front end really helps you, leverage the skills you already have built up with MariaDB if you're already using MariaDB, and also the fact that almost every product out there will have a connector or support for connecting to the MariaDB Server. We support pretty much the full set of ANSI SQL, so you don't need to worry about is this variation of SQL going to be supported by the engine, so complex joins, aggregations, web functions, and so on. We'll get into the details of this more, but ColumnStore is designed to be easy to manage and scale, so it generally needs very limited operational overhead support. I mean, obviously you have to manage your CPUs and your storage and so on, but due to this columnar architecture, you don't really need indexes don't really make sense anymore because it's kind of self-indexing. And also the system supports an automated form of partitioning. And if you can kind of start small with 1 or 2 nodes, and if you find that you need to handle more data or get faster queries, then you can always add more nodes to increase your performance. So with our query execution, you issue your standard SQL to MariaDB Server, and on the back end, we kind of scale that out across multiple data nodes. And we'll use threads, cores, and servers as efficiently as possible to make that query as fast as possible. We also have a very fast data import capability, especially if you're used to, say, using more data than file. We have a utility called CP import, and that works directly with our storage, our kind of storage management layer, and you'll see very fast data import with that. And finally, the system supports HA and redundancy, so that kind of gives you the ability to trust that the system will be resilient, and if you have a server failure, that it will handle it. Okay, so I'm now kind of going to go kind of deeper into how does ColumnStore actually work. So this is essentially like the 10,000 feet view of a sort of a typical production ColumnStore deployment. On the top, we generally recommend that you run a load balancer, such as our Maxmail product. That also supports things like database firewall rules and some other features that can be useful. That kind of goes in front of what we call a user module or UM. This is basically just a MariaDB server, but this is where your queries come in. And then we have a separate class of servers called performance modules, and this is where the data processing happens. So your query gets transformed into a lower level language that is then distributed and sort of map reduced across those nodes. On top of that, the storage that you use for your performance modules, we can support local disk, but if you want to have high availability, we require that you have some sort of distributed data storage layer. So whether that's a SAN or an AS, or if you're using cloud like AWS and EBS, the reason for that is that your data is distributed across those data nodes, and there's only one copy of each node. So if one of those PM nodes is to fail, then we need to be able to mount that data on another node to provide high availability. Questions?
So MariaDB doesn't do any high availability data storage, just the query execution?
Yes, at least in terms of ColumnStore, yes. So if you're using something like InnoDB, the way that there are several ways you can get high availability. We have a product called Columnar, and then you can also use replication to asynchronously replicate your data to a different server. But this is specific to how ColumnStore manages data.
How does ColumnStore manage data? What are you expected to put your data on?
I mean, anything that's mountable on a Linux server, pretty much.
So not something like HDFS, for example?
No. So historically, the product has the capability to use HDFS, but there's some consequences to that, including lower performance. So we'll come back to that.
So I'm curious, can you use this ColumnStore storage engine in parallel with using one of the traditional row-oriented ones, or is this a decision you kind of make at the database level if you go one way or another?
Yes, you can. We have a capability called what we call cross-engine join that lets you run queries against multiple storage engines. So now, in a typical production deployment, most people are probably not going to run their analytics workload on the same server as their OLTP workload, but it's possible.
Sorry,
maybe I'll come back to this because we've got, I'll cover this later. But a key point is that the data is, part of the scale-out story is that we distribute the data across performance modules. So each performance module is responsible for a given piece of data.
So the dialect of SQL you implemented, is that derived from like MySQL parser? Or,
It is the MariaDB parser. So, but one thing we do is that there's a different query optimizer for ColumnStore because most optimizers are really geared towards how do you choose index as well, which doesn't make sense with a columnar storage. I caught a little bit of cough a couple days ago. All right. So here's just kind of a quick primer on what's the difference between a row-oriented database like MariaDB, or a lot of the traditional databases you're used to, and column-oriented storage. So on the top, you'll see kind of bits of that simple people table. And let's say you're going to execute this query, which is select first name, where state is New York. Let's say that you did not have any indexes in this table. You're going to have to scan every row in order to find those two rows identified. With a columnar database, what you're doing is you're essentially pivoting how the data is stored. So rather than storing rows, you're storing columns. Right? So what you'll see here is that there's a different file for ID, first name, last name, and so on. So one of the things that a columnar database can do to take advantage of that is it only needs to scan the columns that are referenced in your query. So in this case, there's actually only two columns that are referenced. So you're probably saving, I don't know, probably about 75% of your I/O already just on that. Because what it needs to do is just needs to scan the state, scan all the state values, and then project the first name values and match that. So that's one way that where a columnar database structure is different, and how you get some performance out of that. So I mentioned our high performance data loading capability. So we have a utility called CP import, and that's the kind of very fast bulk loading capability that works directly with the performance modules. You can either have it distribute the data across them, or you can kind of pre-partition the data yourself. And you can probably get, obviously it's going to vary on your disk storage, but we were doing a test the other day, like for AWS, we were getting about I think about 1 million rows a second data load speed. While you're loading data, the system allows you to continue queries. So you don't have to have downtime in order to run your ETL process. We obviously support all the traditional SQL ways of getting data, like insert, update, delete, and also insert, select, and load data in file. With the columnar data, so one of the downsides of a columnar database is that individual DML operations are going to be slower because in the top here, you're only going to be touching one file, but in the bottom, you're going to touch multiple files. So typically, most columnar databases are going to perform better when you use some sort of bulk loading capability. We also, I'm going to go into more details later, but we also just added a bulk write SDK, and that's essentially considered an SDK or API version of our CP import utility. And how you can see that being used is for to support streaming data sources. Maybe you've got some sort of web analytics product that you want to just listen on changes coming in the queue. Or you want to write your own custom integration or you're doing some pre-processing in some programming language like Scala or Python, and you want to more easily push the data into ColumnStore.
How do
Yep.
you do parallelization of the ingestion? And there has to be some master law.
So, I mean, one of the aspects it's doing is that, so for a given table, let's say you have 4 performance modules. You're going to look, each performance module is going to be loading its portion of the data itself. So that's one way you get that. And then the other aspect is just that there's not a lot of translation overhead between the data import file and the storage format. So, on a
But
given,
how do you access the data as a whole? If you ingest it into pieces, how those pieces are is it a file system underneath, or what's the storage?
yeah, there's essentially a file structure underneath. So,
So is it the same as Hive, for example, does? I mean, they're doing the same thing.
well, I can tell you what this is doing is for a single table, you can only run one data ingestion at a given time, right? So what it's doing is that as you are adding data to the table, what it's doing is it's keeping track of essentially a high watermark, and so the data that's being read will only read below that, and then new data is being appended after that. So I'm not actually familiar with how Hive
So
works.
you don't parallelize ingestion into one table. You're saying it's sequential.
On a given server, but it's parallelized across servers.
But the data you steal and you're going into some kind of data level, how is it connected to the server? How does it matter how many servers? It needs
Well,
to end up somewhere where it's
Because each piece of data is stored on a given performance module server. So there is a orchestration service that figures out to load balance the data across servers, and so it will send, say, 20,000 rows to PM1, 20,000 rows to PM2, etc., etc. Wait for that to finish and then cycle through again. That makes sense?
not really.
Maybe we can talk at the end, yeah.
Question.
Yeah.
Did you say you can load one table at any one time?
You can you can have one load per table at any time. You can load multiple
Okay,
tables.
okay.
You can load multiple tables in
I
parallel.
wanted to have it. Thank you.
So with the column store, doesn't have any support for as-if joins built into the language.
You're talking about temporal queries?
Not by temporal, but if you have trades and you have quotes, right? Then you don't have the equal join there, right? You have to find the latest quote that corresponds to the trade that you shortly after.
So you want to say, given one table, find the next entry in the other table?
Right. So if I had 20,000 trades today
Right.
on Apple, what were the prices that were quoted some number of milliseconds just before that?
Right. I mean, there's going to be several ways you can do that. One is you could potentially use a window function, but sometimes doing some sort of group by, order by type query might be more efficient as well. So it's going to depend on what you're asking and the structure of your table. But there isn't inherent there isn't an inherent syntax for saying give me the prior trade, for example. It's just you use what the appropriate simple version of that would be.
But I guess the question was, how do you synchronize the ingestion even in several tables? In one table, data is dependent on the other table data, and you continuously ingesting, and at the same time you're running the query. That query, may return wrong results because the table's ingestions
Right.
are
So there's a capability. There's a capability where you can specify I would load these, say, 5 tables all at once, and those only when all those tables are loaded and successfully loaded will essentially commit happen. So there's not. I mean, if you decide to load each table separately, then yes, you're going to have windows where where the right side of your join doesn't exist yet. But if you use the multi-table load syntax, then all of those tables will be committed at once.
But when you're talking about high watermark, low watermark, things, I mean, this is already becoming streaming. When it's streaming, there's no time when it's completely loaded. It's all the time kind of loading and loading. I mean, it's completely unsynchronized.
Yeah, I mean that's one of the challenges with supporting a streaming use case, right? Is yeah. All right, so kind of moving into how we manage the storage. So as mentioned earlier, each column is essentially stored and managed separately. So that's kind of a form of vertical partitioning. And then within each column, we have a horizontal partitioning capability. And so basically every 8 million rows or so, we create what's called an extent. One of the other things with a columnar database typically is that the storage assumes fixed length data types. So let's say you have an int column, then it's always going to store 4 bytes for that. If you want to support longer or variable length strings, then how we handle that is that we store a pointer and then store the actual string somewhere else. The reason for that is that you need to be able to project from one column to another. So if you've selected the state column and identified which rows you want to match, then you need to be able to efficiently get the equivalent column values from the other column. So basically, because of this, there isn't. We don't support any notion of indexing. There's sort of a belief that, empirically proven by that indexing tends to sort of break down as you get to much larger data sets. So if you create an MariaDB table with a bunch of indexes, that can work great, but maybe once you get to 1 or 2 terabytes, the indexes start to become more slow because the B tree structure is getting deeper and more costly to navigate. One of the other consequences of storing by columns is that it's very easy to do online and removal columns because you're not able to rebuild a row file. With the horizontal partitioning by column, we also maintain a record of the min and max values in those extents, and then when we execute queries, we can do partition elimination. So let's say, let's go back to the trades and floats example. You're probably going to have a trade date and time. So what you're going to see is that's going to form a natural partition, and then any sort of date range based queries will be able to do partition elimination and only look at the extents where those date values match. And then finally, by default, we enable compression. Right now, we just use one compression algorithm. But the intent here is that, especially if you have, say, a lookup column or something that has a lot of repeating values, that's probably going to compress pretty well. So you can kind of reduce the amount of I/O that you need to do to bring that extent into memory.
Generally, the extent size is I'm saying that it's 8 million rows, extent size relating or extent size, so approximately 100 million.
It's always going to be 8 million rows, and it's actually whatever the choose complement that's closest to 8 million.
Depending on the data type, so the extent size could be different.
No, so right now the software is kind of configured to only support 8 million rows. So that was kind of a balance that we sort of came up with in terms of, in certain cases it might be better to have a slightly smaller extent size, in some cases it might be better to have a slightly larger one. So 8 million is kind of the default that we kind of chose over testing.
So different tables, different types of data types or columns. You have a different instance.
No, this is true of all the other types. So what you would see is, let's say you had a tiny end column. So the difference you'll see is that the extent file size will vary. So let's say you had a tiny end column which we stored in 1 byte. That's going to take 8 meg. But if you have a 64-bit in, then that's going to take 64 meg. Yeah. And obviously you're going to have you're always going to have one extent that is not completely full. Perfect. Yeah.
Why is the sizes are not, why is that arbitrary 8 million rows? The row can be any time, because, person said.
I'm not sure I get the question. I mean, the size, I mean, the system has a predefined size. You can say that's somewhat arbitrary.
No, it's not equal. It's not arbitrary. It's not equal. For every data type, it will be different yield size. 8 million.
It'll be different physical size, but it's always the same number of rows. Because why would you, if you only have if you have a data type that's only takes up 1 byte, why would you pad that to 8 bytes?
I think the point is really relational or scopes. Always window has big size or size fixed and most fitting.
Right, and that's one of their differences with row-based Java. Yeah.
Right, but it's a column, right? So if you're scanning a column, that size will always be the same.
That's what,
Yeah, and yeah, this is, I mean, so there are many other sort of columnar databases out there, but this columnar works very well for analytics use cases where you're doing a lot of scanning or aggregation over a smaller set of columns. So if you take, your sort of classic your by type query, what it can do is it can just read through the set of extents, filtering as it goes, and then adding, doing your sum or average or whatever you want to do. Let's talk about query processing. My slide is missing some background as well. So as I mentioned earlier, you use your existing tools, set SQL to what is the MariaDB Server. We have a ColumnStore storage engine that takes the parse tree and then maps that into what we call a set of primitive operations. And so these are sort of lower level big data operations, if you will, that are executed across the performance model nodes. So kind of an example would be a filter, so implementing some kind of where clause filter, an aggregate, a join, and so on. And that's kind of basically orchestrated by our ColumnStore storage engine. So each node basically takes that primitives, and let's take the example of a filter one. You're going to have one thread that's basically doing I/O reads, and then it does a bunch. It will read a number of blocks or extents, and then it will divide that up and say, I'm going to spawn, let's say, 8 threads to go process that data while I read the next batch of blocks. So that's one way that we get performance. So if you're familiar with distributed data processing, you can't push all of your processing down to remote nodes. So a simple example is if you're doing a sum, you're calculating a local sum on a quarter of the data on each node. So the user module has to do some final processing to add those together. and there's more complex scenarios like aggregate median that require a little bit more work. All right, so here are sort of some of the analytic capabilities that we have. So, we support all the sort of standard complex join, aggregation, window functions. I should clarify this by saying that for joins, ColumnStore supports hash joins. That's not implemented in the standard MariaDB Server. Those are optimized for the cases where you're joining a smaller dimension table to a larger fact table, which is a fairly common use case for analytics. I think I talked about our cross-engine join earlier, so that allows ColumnStore to access tables that are not also ColumnStore tables. Why you might want to do that is you might want to create your fact table as a ColumnStore table and your dimension tables as NODB. Typically, dimension tables are going to be smaller, and NODB is going to give you more capabilities like unique constraints and things that make it easier to kind of maintain those dimension values over time. We also have extensibility capability where you can define and build your own user-defined functions for both scalar and aggregates. So if there's some standard function that we don't have, or we've got some very specific niche use case, then we have a C++ SDK that we can implement and allow you to implement that in a distributed fashion. At the bottom here, this just kind of shows an example of running average for a Windows function. For sort of connectivity, so we support easy integration with all your favorite BI tools. We have an official certification with Tableau, and we're working on some other tools as well. But obviously, you can use the standard MariaDB connectors to integrate with your own application code, either from an ETL perspective or from a display and processing perspective. And obviously, you can use it in, we're here at Galvanize, big data machine learning guys. It's fairly easy to consume, either to read or if you want to kind of push your algorithm results to ColumnStore for later analysis and visualization. You can use it for that as well.
Question.
Yeah.
Do you have the notion of isolation level as well when querying the data for reading, for cursor read, and so forth?
So what we support is we don't support all the isolation levels, but if I'm blanking on the right term for it, quite recommitted, that we won't read uncommitted data.
Okay.
But we don't have we don't support repeatable read.
But
yeah, I mean the way that it's supported is through so for bulk import is through the high watermark capability, and then when we have DML, we have a separate transaction version buffer. So if you do insert, updates, or deletes, we follow the sort of classic model of having maintaining those changes temporarily in version level. Okay. All right. So all being well in about 2 weeks. Oh, do you have a question?
Yeah, I had a question.
Oh, the last. Yeah.
So if your extend files contain a column, right, and they can be physically separate, right? One of them might live on PM.
Right. In a typical scenario, every column will have data. I mean, assuming you have enough data, right? But every column will be spread about as evenly as possible across the PMs. And so like, let's say you had 32 million rows and 4 PMs, then you would have extent 1 would be on PM1 would have 8 million rows, extent 2 would be on PM2 with 8 million rows, and so on.
For each column?
For each column, yes.
So you extend-
Because remember that the art of the columnar database is that you're storing and managing each column's data separately, right?
Which is why I assume they could not separate.
So you don't. So you can run a single server column store instance. the reason you would have multiple PM servers is that you want to. You either want to handle more data in the same amount of time, or you want to have your queries run faster, right? Because you're distributing the load. So if you go from like 2 PMs to 4 PMs, you know, theoretically, the same query and the data was redistributed. Theoretically, the same query would be twice as fast.
Okay, but
Right.
what I'm asking is not about distributing row memory,
Okay.
column memories. So if I have a table, 2 columns, I might only want to store that in a single gem. So if I have a table with a million columns, then I might want to have multiple gems, and I need to find out where a few rows in that table.
So if you had multiple PMs and you had a smaller table, so there are ways you can kind of override this, but the default behavior would be that I think it's every 20,000 rows it switches PM. So your data, even for a small table, your data would still be distributed across the PM servers.
So it's not distributed.
But let's say you only had 10 rows. That might be a case where maybe you actually just want to store the data in ODB, right? Because
Right, but if I have 10 rows and each row is a million columns, then it seems like usually if you're using a ColumnStore database, you should be able to shard columns, right? Like that, you should be able to separate them, but still have separate row issues.
if I understand what you're saying, I don't think we support that capability. I mean, it's theoretically possible,
So
but
for any given row index, all the columns must be in the same gem.
yes, yeah. So a given row, the column values of that row will all be on 1 PM, yes. And that, I mean, again, that's something you could decide not to do, but especially in the case that you're doing, you're scanning one column, projecting another column, there's some advantages, some performance advantages to not doing a network round trip.
It sounds like you don't really want to have blind tables.
Right.
You don't want to have blind tables.
So actually, yes and no. So columnar databases are designed to support are designed to support wide tables, but they're more optimal if you're only referencing a small number of columns. Right. So the cost of adding a column for some value that's not used very often, that's not going to impact your existing queries. But in a role-based system, that would impact them because now you're doing a little bit extra I/O.
Right, which is why you might have very blind tables.
Yeah.
Which is why I asked if you could shard it that way.
So what you're saying is, for table X, columns 1 through 1,000 or 1 PM, and columns 1,000 to 2,000. Yeah, interesting idea, but we don't support it. So. I mean, if you're familiar with MariaDB and MySQL, there are some limits in the total number of columns you can have as well. So.
I'm more familiar with HBase.
Okay, yeah.
Yeah, but that's the difference. That's
Yeah.
the question that I would do. So you still go with clear separation, what is row, what is column, right?
Yes.
You don't go into this column family kind of
Yeah, and
databases
that's why this is more
Right.
because we are maintaining more information and understanding of the data. It makes it easier to have a proper SQL implementation.
So the idea is that this still relational. This is still not
It's-
kind of completely, because this wide column means not just that there are multiple number of columns, like thousands or millions. That means that even the name of the column can be any arbitrary, byte array. So in that sense, the column does not actually mean column in the relational database sense.
Yeah, you're correct, yeah. So this, comparing it to HBase is a good example there. So.
It's completely different. It's still relational database architecture.
So that's what makes it more amenable to full SQL implementation.
Also, white table is the more columns you add, it's probably going to have the table become null or expressible anyway.
Yes.
Right, but in column family databases, the nulls are not stored by design. It's not like it's compressible or not compressible. It's like, those column family databases are more like the spreadsheets than the databases in that sense. So if the cell does not exist, there's no footprint at all. So it's not like the column, the nulls are compressible. They don't exist at all.
Right. Yeah. Okay. All right. So in probably about 2 weeks, we're planning to release our GA version of our next major release, which is going to be our 1.1 release. So we'll talk a little bit about some features we're adding into that. So I won't read all this. It's kind of very verbose, but one of the first things we've done is we've upgraded the base version of MariaDB Server that we ship with to 10.2, and we're now working on 10.3. We added support for streaming use cases. We heard from a lot of our first customers that they were interested in some kind of support for this. So either, for example, being able to connect up to a Kafka queue. So a lot of organizations already have either a third-party system or in-house system that's publishing events that are of interest to a Kafka queue. So adding support for that. For high availability, I think someone was talking earlier a little bit about the requirements in the storage. So, since this is an MPP architecture, each PM node is responsible for its portion of the total data set. So in order for another node to act on its behalf, should that server fail, the data needs to be made accessible to that node. So with our current version, you would have to use either a storage appliance or some sort of software distributed file system software. So we kind of looked at the options available, and there's a few out there, but we decided that GlusterFS was quite a good fit for us to run as running Gluster on each PM server, sort of in an embedded fashion, and then let Gluster take care of the data replication to the other nodes. We added user-defined aggregates. We also added text and blob, and a bunch of other stuff. So one of the things that I'm kind of personally most excited about is our data API. So we're starting out by adding a bulk write API. The intention is to add a bulk read API that would be sort of NoSQL-ish, so be below the SQL there. So this basically gives you an API version of our bulk import capability, and you can kind of then integrate that into your custom code for your ETL process, or if you've got some upstream machine learning processing, have that code directly push the data to ColumnStore for future analytics. So the main database is built in C++, so the base SDK version is built in C++, but we have bindings for Java and Python, and can add other ones as we need. One other important capability is that our bulk import capability requires to be run on one of the ColumnStore servers. the API will basically allow you to run on a different server, which can be useful. And kind of with that API, obviously it kind of makes sense for us to look at the most common solutions or type of problems that people are trying to solve with it. So we're going to come out with what we call data adapters. And so one will basically be to support a scalable form of change data capture replication from MariaDB Server. A question I often get asked is why can't ColumnStore, if you're familiar with MySQL or MariaDB replication, why doesn't ColumnStore support acting as an application slave? The reason for that is that DML is very inefficient, and so we fear that in a real production system, it would never keep up. So what we wanted to do was to interject a layer where that could kind of feed through this bulk SDK to make that scalable. And then I kind of talked about the Kafka integration as well. All right. So we had user-defined functions in our first version, but we added user-defined aggregates in 1.1. So this lets you implement the equivalent of, let's say, a sum or average function, and make that distributed so that the execution will scale out across the nodes. It's also a C++ SDK, this is C++ database. So basically lets you write, or lets us more easily write custom aggregate functions. So we added a couple of reference examples, some of squares, probably not all that useful, but, and then a distributed median function, which is really cool. Okay, and then here's kind of just a slide going into more detail about what we call our data redundancy feature. So what this lets you do is, when you're setting up the software, the system will say, okay, I see you've got Gluster installed. Do you want to use our data redundancy feature? And the install will say what data redundancy factor do you want to use. So I essentially how many copies of the data do you want. So typically you want at least 2 or 3. And so then that's going to go off and then set up, do all the cluster configuration, and also optimally create each cluster brick in the most, which is kind of its term for its storage volume, such that, so let's say you had total data redundancy factor of 2, you can support 1 node failing. If you had data redundancy factor of 3, you can support 2 nodes failing. So the reason we did this was we had a number of customers who were who didn't really want to go and buy some kind of network storage appliance and were a little wary of kind of setting this up themselves. So this basically gives an easy option if you want to run this on your own hardware and you don't have sort of a NAS appliance, if you will. We also might use it for some cloud providers that either don't have or don't have very good distributed storage capabilities. AWS does, for example. And the diagram just kind of shows you, let's say PM1 fails. You can sort of see that data block 1 can be handled by PM2. They have a copy of data block 2, so PM2 continues to support data block 2, and the same with data block 3. So that allows the PM1 server to fail and the system to kind of continue to work. All right, questions?
So you use only Gluster as base distributed file, you don't enter to HDFS?
Not yet.
Why did you choose Gluster and not HDFS? Gluster looks like 3 years.
We chose GlusterFS. So one of the problems with using HDFS is that we inherit a bunch of problems from the eventual consistency model is the main reason.
Attention.
Yeah.
HDFS is not attention. It's a stronger. It's not Cassandra.
Yeah.
And then there is a MariaDB.
Right. Yeah. I mean, I think we sort of felt that GlusterFS was more file system oriented and a little bit more lightweight. We'll see if that proves to be the case or not. So, I mean, we could support, there's no reason why we can't support other software-defined storage, like, Red Hat also has SAC, and there's another one that I'm blanking, maybe DRBD or something like that.
It's just the class. I mean, if you will go, for example, to the wirefest, then you will be kind of Python defender, which gives you much bigger exposure.
But I think, I would also say as an open source product, we're probably not going to want to build our solution on commercial software. So, Hadoop is, but not large enough.
So essentially, the storage layer of this is not actually distributed as far as MariaDB is concerned. It's like a single point of failure, right? Like,
Yeah, so that's
implemented something to try and
Right.
work with that.
Yeah.
With the automatic cluster.
Yeah.
It still treats it as a single file system. As
Yeah.
opposed to a single file system.
No, but the processing level is. I mean, in that case, I mean, if it will be instead of let's say HDFS, then it will, put it head to head with Hive and Tree and other stuff.
But that's what I'm pointing out. So the way it has been described so far, it's not good. So you
Right,
can't really
because it's
take
much
advantage
bigger
of
problem.
locality
Yeah.
or anything like that.
I mean, we've sort of taken, this is always a big internal debate as to whether we should take care of data replication or whether we should continue to rely on the storage layer providing it. So,
Do you allow querying against all the nodes at all time?
well, yes, because in a normal system, you're going to have to query data from every node because the data is spread out across.
No, what I meant to say is, so you have node 1 and node 2 that has block 3, data block 3, and a copy. Are the copies being used during querying?
Oh, no, yeah, good point, yeah. So in this setup, only the in a normal where all the servers are at, only the primary copy is being used, and then the copy is essentially just a failover copy.
So you just talk about the one with the levels. It's like up to the implementation of the
Disaster recovery, yeah, sure. So this basically gives you high availability. For, let's say you wanted to do geographic disaster recovery. It's something that we're looking at our roadmap, but what we recommend that you do right now is that is to basically take your ETL process and replicate that to your second instance and basically double play it. Also coming back to HDFS, I think historically we found that there was some performance overhead using HDFS or native file systems as well. So it's something, as I said, it's something that's in the code base that we inherited from InfiniDB. That, to my understanding, it was built, but not a lot of people ended up using it. And probably for a lot of that reason.
But it used clusters completely open source, or that belongs to
Red Hat is the corporate sponsor for it, but it is still open source. So you don't have, like MariaDB, you can choose to use it without paying for a support subscription. But if you do want to use it, but if you do want a support subscription, Red Hat's available to provide that support for you.
I remember this is also the same level. In your community, it's free.
Sure.
Only if you need support.
Yeah, sure. As I said, that's not, I mean, again, it's something we can kind of look at in the future. All right, so we're going to switch gears and just talk about, what some of our customers are using ColumnStore for. So I'm going to cover these four main areas, so financial services, healthcare, telco, and high tech. So looking at the financial services industry, this is kind of a couple of use cases that we've seen. So the first one, and this is one of the reasons why we prioritized adding text and blob data type, is being able to take your OLTP data and store it in ColumnStore sort of as an archive. So if you need to retain that data, but you don't want to keep it in your production OLTP to keep that lean, ColumnStore can be a good use case for that, and obviously you retain full SQL access with that. We talked about earlier about trade analytics, so obviously a fairly common case is going to be load a bunch of trades and quotes and do some analytics on that. So again, you're why MariaDB ColumnStore, so we're cost effective. Your data load is going to be fast and easy to analyze with SQL. We cover the healthcare and life sciences industry. So first one is Genome Analysis. So this company is in the business of figuring out how to breed cows effectively, which is a very fascinating topic. So they have some machine learning algorithms that they've developed. So they run that in Python, and then what they do is they push the results to ColumnStore so that they can have a historical archive and easy access and visualization to available. On the next one, healthcare spending analysis. So this was actually our first customer, and they actually went into production on our first beta release, and it worked fine. So there's an organization called the Institute for Health Metrics and Evaluation, and so they're basically in the business of gathering either automatically or manually a huge amount of data points globally around how can you be more informed about causes of death or causes of illness, and this all this data is available publicly. So they started out having built their platform on MySQL. They ran into scale problems. They deployed Percona cluster, used all the Percona performance engineers they could, still ran into scale problems. They switched to ColumnStore, and that kind of solved all the problems. So it was a pretty nice story. These are just some examples of some of the charts. I believe the chart on the left, wow, what do you want to say about the side versus the closest? I think this might be to do with expected or life expectancy by county. And on the right, this is I think this is a Sankey diagram, basically kind of showing mapping kind of age groups to different types of diseases. So as you select, say, less than 20 years, you're probably not going to see too much cardiovascular. So this lets you really kind of see some fairly interesting data analysis.
Can you put the financial back, please? 1 second. Can you put the financial one slides back?
Okay, where's that back up?
Thanks.
And Eric, I think this is, here's Eric.
Thank you.
I believe also this is being recorded as well.
Okay.
Actually, I have a question about this slide.
Okay.
So for the archiving use case,
Yeah.
So what exactly is it about the columnar store that makes it better than a raw one? Is it that compression is more efficient?
So compression is going to be one thing, and then as your data gets bigger, it will be able to kind of scale out and handle larger data sets more efficiently. But I would say that probably the primary one is going to be compression, because you're compressing the data, and then you're also not having the overhead of index storage as well.
Well, you can maintain a low-oriented table without indexing.
Yeah.
You have much bigger impact on insertion in columnar data storage, because you ultimately need to open all of these pieces.
Well, that's why an insert into statement is going to be less efficient. So you wouldn't want to run your OLTP application on ColumnStore, but it's obviously very easy to do some sort of periodic bulk extract from your OLTP and then bulk insert that.
If it's bulk.
Yeah, and in this case, I think it was like, I can't remember if it was a weekly or a monthly job, but yeah. And so switching over to telco, so doing customer behavior analysis, so having ColumnStore ingest all of the call data record data, so you're doing all your kind of classic segmentation, slicing, and dicing, and using that to kind of improve the customer service application to just kind of offer up maybe sort of relevant upsells. So don't ask me if I want a cell phone, I already have a cell phone for you. So. And then obviously, using the same data to do sort of call and network quality analysis. So, are you undersized or oversized in a particular location for calls? All right, kind of last one, high tech industry. So the first one is, this is one that always I find very interesting, is they're using us to, this company basically does, as part of their development process, they do a lot of simulations and tests on actual chips. And so there's a very large amount of data comes out of that, and one of the reasons they really like ColumnStore is because of the fast data loading. Because for them, what they're actually doing is they want to just load that data, do a bunch of number crunching, store some aggregate results, and then move on. So they have a very high volume of data, and the data is sort of high value for a day, and then low value forever after that. And then finally on sensor analytics, so taking data from multiple IoT sensors and then doing time series analysis, or trying to predict patterns and anomalies. All right, so I think I remember from the quiz earlier, we have our MariaDB user conference coming up in February of next year, right here, down at the Conrad, Galloway. So we have a good deal here. I think Eric is going to probably mail this out as well. So we have for you guys, we have this pretty good pricing. So you get free registration, basically just pay for your technical workshop. So the code is MariaDB and just go to our ma18.mariadb.com. And so we'll have lots of sessions from MariaDB engineers like myself, as well as customers talking about how they use our products. And so not just ColumnStore, but all of our products. We'll have a bunch of technical sessions on ColumnStore, as well as a training workshop as well. All right. So questions?
Before we take questions, I just want to point out, we are giving away this Vive in a few minutes. Anybody who wants to have a chance to win it has to put your business card in here or create a business card on a piece of paper with your full information. Oh, you have it on the other side. Okay, I was about to give it back. Yeah, okay, just you can come up here and put it in. You got a few minutes left before we give this thing away. Let's take the next question. You had your hand up somewhere there.
Yeah.
So essentially, MariaDB ColumnStore is sharding and column-based partition for people who are already using a SQL database and their analytics are now at the point where they need to shard for these.
Yeah, that's one way. Yeah, I think we also see some customers who have made an investment in other tools like Hadoop, and find that it solves some of their use cases, but a lot of their users like the ability to use their favorite tools like Tableau and how full single part.
So, sorry. What about, have you guys compared this at all to Hive? Solutions stand up?
Well, I would say with Hive, for what it does, Hive is great. ColumnStore, the ColumnStore will probably perform better for most queries. I'm sure there will be cases where you can say, okay, Hive does better in this case. I think the challenge with Hive is that while it is, a sort of standard, it isn't as broad a standard as SQL, and so it's just harder. It's harder for more people to consume.
My next question is pretty much similar. How is it different, or have you tried to compare this net to Apache Spark or an engine sitting on maybe HDFS database or a huge database and then processing at high speed using in caching?
So with Spark especially, I think Spark's a great product, and I think there's certain things that it's probably better at, and so if you want to use ColumnStore as a data source or just a data store for your processing in Spark, that's completely fine. I think for every sort of product, there's going to be some things that it's going to do better at or worse at. So Spark is going to be bound by the fact that it's inherently in memory, right? So that would be one case where it has some capability to do filtering on disk, but.
So I want to ask you for some guidance on how an analytical query might perform. Like, what's the trade-off on performing an analytical query on this columnar store versus the row store? I want to ask you, kind of forgetting about the distribution aspect, so forgetting about the distributed execution in one case, so comparing one server to one server. Because I imagine that on one hand, with columnar stores, you get better I/O characteristics that are more compressed, whatever. On the other hand, you kind of have to join those together as soon as you, extends, I guess, together as soon as you access multiple columns. And you kind of hinted at the fact that you maybe want to use this for queries that access a small number of columns. So is there a rule of thumb for thinking about these things?
So if you're always writing select star queries, then columns, and this is not just true of ColumnStore, any other columnar databases, they're going to be slightly less. That's probably not exactly their sweet spot. But columnar storage and columnar databases came about from the fact that the vast majority of analytical queries or individual queries are accessing a few columns. It tends to be like the select product sum price type query, but also the fact that the types of query are truly ad hoc as well. So you can't really predict like in an LTP database, what are going to be the common access paths. And so the columnar storage sort of gives you a means of supporting a broader set of ad hoc queries efficiently over, role-based storage or some other means.
So that's a two-part question. So I understand it's a commodity rather than
Yeah.
how many indicators it's supposed to be important? Because basically the job across the module, but some of the least source part of complement in the structure.
Yeah. I mean, so it is a distributed database, and so there is going to be network traffic both for data loading and for queries. So, I mean, I think any sort of modern, any sort of, obviously if you have a 10G or a 40G network, that's great, but, we have plenty of customers who are running on a 1G network, and that's good enough. It sort of also depends on the type of query you're running. So, let's just go back to like the Slack product some price example. Let's say you only have like 200 products. The actual amount of network traffic that's going to occur as part of that query is going to be pretty small, right? Because you're only passing down the instructions, and then you're passing up the intermediate, the aggregate results from each PM.
But you don't try to distribute processing for 300 products. I mean, that's not the point. When you're distributing, it probably millions and billions of data points.
Yeah.
So in that case, it's very relevant.
Right. So the other way that we get performance is through the partitioning. So, right. So basically, if you have a word clause, right? So.
How do you deal with transactions?
So for the bulk CP port, so that follows the high watermark model. So a particular bulk import job will either transaction succeed or fail. If you're doing DML, we have a separate version buffer that maintains the changes until commit. So basically, you'll always get consistent queries.
He had his hand up.
Yeah.
So consistency, availability, and partition developers.
Mm-hmm.
Which are the two things that everyone focus on? What does it sacrifice for? Availability. How does it offer high availability? I'm not high availability, as to
Yeah, so if you're following cap theorem, we sacrifice availability. Yeah. And so we mitigate that through the ability to to have another node act on behalf of that. So that's inherently, whenever you partition data, that's an inherent aspect of that. So.
But that is what simplifies the transaction. So the availability in that sense of all the transaction. You cannot finish the transaction that would just break it.
Well, so if you're in the midst of a transaction and the server went down, then that transaction would be rolled back. So
You cannot guarantee any transaction. The same way as
no. Well, so if you have a particular PM node, kind of become non-responsive or go down, then the commit would not succeed. So there is coordination amongst the PM nodes as to when a commit can take effect.
That's the case that everything is fine, but there is a partition, then you cannot guarantee it. Because this is the world of Hive and other Hadoop systems, and there's a reason why none of them, go into transactional models. You say you do it, then you say you go into distributed, processing. Mm-hmm. There is a disconnect here.
Well, I think the first thing is that, columns. I wouldn't say that ColumnStore has strong consistency on writes. So so in the case that you have a partition, i.e. a PM server go down, then what's going to happen is that whole transaction is going to fail. So we don't have the ability to tolerate that. So that's your question.
Let's take it offline. Last question.
Yeah. You mentioned query types before. How do ColumnStore database respond to recursive queries? And how do they measure against graph database?
So, good question. So, MariaDB Server 10.2 actually added support for recursive CTE syntax. We don't. So we
They don't support them.
No, it was added. It was added in MariaDB 10.2, but we haven't done the work to make that work for ColumnStore. So,
Okay, David Thompson will be here for one-on-one questions, as well as Bob Hesser, the senior account manager for MariaDB. Feel free to come up here and ask questions to either one of them. Before we do that, I want to give a great big round of applause to David Thompson. And now we're going to give away this awesome HTC Vive. I'm going to go. Can I ask you to just mix it all? You're not going to pick it. Just mix it. Can I ask you to reach in and pull out a card without looking at it that way? We've actually had that.
Victor.
Victor.
Victor.